Structure of glucose. Glucose is the most widely used aldohexose in living organisms. Glucose is also sometimes called dextrose due to its dextrorotatory nature. It is the monomer of many of the larger carbohydrates such as starch, cellulose. It is the most important simple sugar in human metabolism. It is probably the most abundant organic compound on Earth. It was assigned the structure given below on the basis of the following evidences. 1. Its molecular formula was found to be C6H12O6. 2. On prolonged heating with HI, it changes to N-hexane, indicating that all the 6 carbon atoms are linked in a straight chain. Glucose reacts with hydroxylamine to form an oxime, and with hydrogen cyanide it forms cyanohydrin. These reactions indicate the presence of a carbonyl group less than C is equal to 0 in glucose. With a mild oxidizing agent like bromine water, glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid. This confirms the presence of a carbonyl group as an aldehyde group. When glucose reacts with acetic anhydride, it gives glucose pentaacetate, which confirms the presence of 5 OH groups. Since glucose pentaacetate is a stable compound, this indicates 5 OH groups should be attached to different carbon atoms. Glucose as well as gluconic acid, both on oxidation with nitric acid, yield a dicarboxylic acid, saccharic acid. This indicates the presence of a primary alcoholic OH group in glucose. The exact spatial arrangement of different OH groups was determined by Emil Fischer, a German scientist, in 1891. The exact configuration of glucose molecule is represented as: glucose is correctly named as D-positive glucose. D represents the configuration, whereas plus represents dextrorotatory nature of the molecule. Cyclic structure of glucose. The configuration of aldohexose glucose molecule as given by Emil Fischer could not explain the following facts and reactions. 1. Glucose does not give 2,4-DNP test, Schiff's test, and it does not form the addition product with NaHSO3, showing the absence of free CHO group. 2. The pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. 3. Glucose exists in 2 different crystalline forms called as alpha and beta. The alpha form of glucose has MP 419K. The beta form of glucose has MP 423K. This behavior could not be explained by the open chain structure for glucose. A cyclic hemiacetal structure of glucose was proposed, in which one of the OH groups adds to the CHO group. It was found that glucose forms a six-membered ring in which OH at C5 is involved in ring formation. This explains the absence of CHO group and also existence of glucose in two forms. The two cyclic forms exist in equilibrium with open chain structure. Isomers alpha form and beta form are called anomers. The six-membered cyclic structure of glucose is called Pyronose structure, alpha or beta. The cyclic structure of glucose, as represented by Haworth structure, is given below. Fructose. Fructose is an important ketohexose. It contains a ketonic functional group at carbon number 2 and 6 carbons in straight chain. It belongs to D series and is a levorotatory compound. It is appropriately written as D minus fructose. It also exists in two cyclic forms, alpha D minus fructofuranose and beta D minus fructofuranose. The cyclic structures of two anomers of fructose are shown as